aggregate of metalliferous minerals, not necessarily single, there can be more, and they are more or less mixed with gangue. So we are introducing another term, gangue. We will define what is gangue. Gangue, which from the standpoint of a miner, miner means mining person, okay, a person who is investing money to mine out, it can be one at a profit. So for him, a ore has to be one that you take out from the earth and it gives profit. Or from the standpoint of a metallurgist, because a lot of metallurgy people involved in this processing of minerals, metals, when we extract metals, they're called as mineral processing engineers, metallurgists, okay. So for them it is, the ore can be treated at a profit, okay. Number of times the ore occurs at a low grade. You have low grade, or also called as lean grade. You will not have much concentration. So we have to treat it, called as ore treatment. In fact, there are a number of courses. If you go to metallurgy, that we call it as physical metallurgy, especially the called as the extractive metallurgy. So they treat it. So based on the miner's point of view, the definition will vary. Based on the metallurgist, it will vary. But let us try to see what is more specific definition. Yeah, yes. So this is what given Evans. I think probably I don't know how many of you have read the book called Evans. It's a very beautiful book. I think some of you can download this book. It's a nice book. Evans. Ore is one. It's a material from which we can extract a metal, and this operation must be a profit-making one. This is a more combined. It combines a lot of things, and finally, it gives a good definition. So that means you have to extract a metal, and the operation will be profit-making one. Okay. So I think probably like during our discussion number of times, you use sometime ore minerals, sometime you industrial minerals. Let us try to see what is the difference. Okay, sensu stricto. So people call it as ore minerals from which a metal is extracted, or you can extract more than one metal. For example, you take galena. Galena. I don't know. I think many of you must have heard the term called galena. Okay. Galena is basically lead sulfide. So lead sulfide. Lead sulfide. Lead sulfide. So naturally, when you have ore of lead sulfide, you have material which is having a lot of combination of lead. So you can tentatively extract lead. That is one thing. Sometimes what will happen is the lead, when you try to extract, some of the byproducts also come out. Okay. So people have observed this galena can give rise to silver, cadmium, sometimes even cobalt. So all these things are inside the crystal lattice here. So when they are inside, you do not know, you cannot see outside, you just only see the mineral, but it's inside the structure. So when you go for operation, when you go for the mineral treatment, so many of the things will come out as a byproducts. Okay, so that's why it's called as the metals. Okay. So example, chalcopyrite, galena. Okay, from chalcopyrite you can extract copper, from galena you can extract lead. But sometimes you can also chalcopyrite can give rise to gold. People have observed a lot of gold is coming out. Sometimes from lead, silver is coming out. Is it right? And another term generally used is called industrial minerals. Okay, basically for industrial purposes, which is sensu stricto, it is non-metallic. So some example is barite, asbestos, limestone for cement, talc, pagrasite. So there are a number of industrial minerals which are non-metallic. So sensu stricto, when it comes to economic geology, you have two major divisions. One is called as ore minerals, another is called industrial minerals. Ore minerals is something to do with the metallic, and industrial mineral has to do something with the non-metallic. But for a layman, they all look alike. It's all the same. But when you go specifically, there are distinctions. Is it clear, Nikhil? Nikhil, is it clear?
Yes, sir.
Okay. So another, we introduced a term called gang when we're discussing about ore. So let us see what is a gang. Okay. So these simply the unwanted material. It can be mineral or can be rock, with which the ore minerals have usually intergrown. A simple example. You go to, I have shown you a number of pictures, the field pictures in the previous classes, you will have veins. Okay, so let's say it's a quartz vein. Okay, quartz vein. The quartz vein can have gold, it can have tungsten, it can have some other metals, tin. Okay, so let us consider this is a quartz vein carrying some amount of gold. Okay, so such a vein is called as the auriferous quartz veins because they have gold in it. Auriferous quartz vein. Suppose you take auriferous quartz vein, the gold is only a small part of it, dispersed here and there. So ore, this gold becomes the ore, native metal is ore. Okay, all right. Our ore mineral, what you call it as. Then what are the remaining 99% is quartz. So this quartz now is becomes the gangue, unwanted material, because your main aim is to extract gold. So quartz becomes a gangue. Okay, so it may vary from mineral to mineral. For example, you have calcite vein. Let's consider it consists of a little bit of galena. Okay, so calcite becomes a gangue, and galena becomes the ore metal because all of them were forming together. Okay, and certain terms we will come across called ore concentrations, some terms called tailings. Okay, so you find out from books. Please read some books. Okay, so I expect that you also should do some work. Okay, find out from books. And another term generally used in economic geology is called as proto-ore. One is ore, another is proto-ore. What is a proto-ore? So this is mineral material in which an initial but uneconomic concentration of metals has occurred in the past, that happened in the past, that can be further natural process, be upgraded. So do you understand this? What is happening? Saket, do you understand? Do you understand
Yes, sir.
what is? Can you please explain me?
Some initially the concentration is not up to the mark, so but by natural processes, it can upgrade it to the level of ore.
By artificial process?
Natural processes.
Natural process. Can you give an example of proto? If something is there in your mind?
No, no, sir, not
Okay,
now.
Sakya. How about Raghav? Raghav? Raghav?
Yes, sir.
Please, can you please tell what does it mean for proto, and do you have any natural example?
Sir, sir.
Mr. Amit Yadav? Mr. Amit Yadav? Ankit? Ankit? Royal? Can I speak to Royal?
Sir,
Hello, Royal. Good morning.
good morning, sir.
Hope you had your breakfast in the morning.
No, sir.
No. What is the time now?
10:19, sir.
10:19. What time you got up?
9 o'clock, sir.
9 o'clock. So what were you doing after 9 o'clock?
I was doing some other work, sir.
Okay, anyhow, it's all right. That is your personal. Okay. So tell me one thing. Have you heard of this term called proto-ore?
Sir,
Have you heard of this term called proto-ore?
earlier, no, sir.
Earlier, no. So do you understand anything? What are that is appearing on the screen?
Sir,
Do you understand?
yes, sir.
Yes, okay. Can you give a natural example? When now you are in third year, you complete 2 years of, are you in geology or geophysics?
Geological technology, sir.
Very good. Wow, beautiful, excellent, very nice. So can you just still give me a natural example of a proto-ore?
Exactly not, sir.
Anyway, you write an assignment on proto, okay? I want Royal as well as Amit Yadav, both of them to write a small assignment for about 3 pages on proto, okay, and submit it through internet, through mail.
Okay, sir.
Okay. Yeah, anyhow, now let me just tell. One small example of proto is, have you heard of the term banded ion formations, BAF? How many of you have heard term called BAF? Banded ion formation?
Yes, sir.
Yes, sir.
Okay, very good. May I know who spoke?
Saket.
Nikhil.
Saket. Oh, very good, Saket. Okay. Have you seen banded ion formation? Have you seen a sample of banded ion formation?
Yes, sir.
Very good, very good. Can you tell what exactly BAF contains or it consists of?
So means there are bands like alternate bands of iron in that.
Very good, very good. Okay, iron. Other iron. What do you have? What else do you have? Yeah, it's known because banded iron will be there, bands will be there. Okay. So other than iron, what else will be there? Suppose if I
Quartz.
take a rock, like this, I am seeing some bands. Let me see some bands. Okay. Okay, these bands will be having certain minerals. Let us call it as iron. Okay. Iron. It's not the element. It will be having magnetite, hematite, goethite. Okay. These, if you try to study these part, they'll be having magnetite, hematite, goethite. Okay. What about these part? What about these dots that I'm putting? Have anyone of you have got an idea? How many of you completed sedimentology course? According to me, it is just not only just completing the syllabus, just talk something and just PowerPoint, put something will come, and you people listen something. Unless you learn something from the teaching, my feeling is that it is absolutely useless. In fact, I am also wasting time. You are also wasting your time. So I think something is wrong somewhere. So
So
let
is
me
it
tell you.
silica?
Very good, very good. So what do you mean by silica? Next, my question.
Quartz.
What do you mean by silica? One by one. Yeah, only one person. At a time, one person.
Here it will
Saket
be quartz.
is it Saket is still speaking?
Now Nikhil.
Nikhil. Okay, very good, Nikhil. Okay, good, very good. So silica. Silica is SiO2. So it can be a quartz, it can be a jasper, it can be a chert. Okay. Okay. So you are telling quartz. Okay, doesn't matter. Very good, very good. Okay. So it may be having quartz. Of course, apart from quartz, you can have anything else also. Okay. So you have layers to start with, which are iron and which are silica. So if you try to analyze these rocks, if you take a sample of this rock, if you try to analyze, it will give SiO2 composition. Is it right? And it will give a lot of Fe2O3 or FeO. So basically silica and iron. Okay. So that means there is something happening between iron and silica. Okay. And if you want 100% of the analysis, silica will be having maybe around 50% or 55%. Then iron will be having 45%. Is it right? Sometimes the silica will be so dominating, it can be even 60% silica, and iron will become Fe will become 40. But if you go to the metallurgist and tell that I have a ore from a particular area which has consist of 60% SiO2 and I have got 40% of 40% of iron. Of course, other than this, you have other compounds like magnesium, you have silica. Silica is one. Magnesium, aluminum. Sometimes you will have. Okay, I'm not worried about all those things. So let us take only Fe and Si. If you go to metallurgist and say that I have a ore, we are having 60% of silica and 40% iron. So can you process it to become a steel? He will say no. I am very sorry. He will say that please bring a ore which is having minimum of 55% of Fe. Then you will ask the question why? Then he will say that if I want my plant, my metallurgical plant or the steel plant, if some of you are coming from Bokaro or from Bhilai or from Jamshedpur, probably many of you must have seen the steel plant. Okay, the blast furnace. Probably you must have studied your chemistry. Okay, so all these things are happening within the blast furnace. So the blast furnace requirement is 55% of Fe. If it is less than that, your blast furnace will not accept. Is it right? Right or wrong? Ankit? Ankit is not answering. How about Saket?
Yes, sir.
Is it my line of discussion is okay?
Yes, sir.
Okay, done. So if that is the way, then you don't have any other way, but you have mind the war. Is it right? You have mind the war. So what you will do is you will go for some artificial treatment. That is one thing. Otherwise, if you search in the whole area, some places you will have packets of the ore which was already upgraded by the natural process in the geological past to a higher level. Okay. So that type of ores are called as protors. So that means vanadine formation is basically a protor which, because of some natural process, it went on leaching, and after some time, it has given rise to a excellent formation with around 60%, 70% iron. Okay, such a ore is called as protor. That means the ore gave rise to this 70%, 80% of iron is called as protor. So basically, the vanadine formations are protors, original material with uneconomic concentration. Am I right? VAF, original, it's having uneconomic. It's having 60% of silica and 40% of Fe. But in some parts of the deposits, if you try to search, that is the job of the geologist. Okay, you will have some packets where you will have 60%, 70%, and all these things was done by the natural process. So such a ore is called as proto. Is right? And the ore that is having 60 is called as the enriched ore. We will read all these things later. But please go through all these things. Okay. Next term is ore body. Of course, people use ore body term. Economically mineable aggregates of ore minerals, ore deposits, ore bodies, some of the ore shoots. All terms are used. Okay. Probably you will come across during your studies. Now let us try to see certain aspects, because always if you want to look for a good future, people say don't only look for the present, look for the past. Okay, look how things develop and how things are developing, so that accordingly we can predict for the future or we can work for the future. Okay, so let us see how natural resources were utilized by mankind right from the early days. Okay, is it right? So this is called as historical development of theories in ore deposits. Okay. In fact, people think that no, like for example, a student coming out of MBBS after 5 years plus 1 year internship, he feels that, oh, I have done achieved anything, oh, I know everything. But when he goes and meets a doctor, okay, then he will come to know where he stands. Okay, the same way we also do a lot of things, but we come to know when we try to see the history, how things develop. Okay, so that means that is great. So we will also develop. In future, people will say that yes, in 2020 people did like this. Okay, so let us try to see how people were. So the first earth material used by primitive man, non-metallic. Originally they were used non-metallic, like flint, like chert, quartz, obsidian, quartzite, soapstone, limestone. What for they were using? Because primitive man was always was fighting against nature. Okay, or he was hunting animals, so it was used as weapons. Later is used as utensils and for carving. So they were knowing what type of rocks are good for carving. Soapstone is very good for carving because the hardness is very less. Okay. And they were preparing potteries and bricks. They were knowing how to use clay. 10,000 BC in Egypt, the most famous. The pyramids, okay, a particular place has got some of the best pyramids. Okay. So one particular pyramid, they were using 1, 2, 3,000, 10,000 lakh, my lord. So many, 23 lakh blocks of stone were used. So you can imagine the nature of people, okay, working on all these things. Yes, it's called a Neolithic. People started using rocks, and of course, called Paleolithic and Neolithic in history. So if you try to see Neolithic period, they were more acquainted with the gold and copper. Yes, now things started becoming better. They were knowing metallic things. And they were using sillimanite, turquoise. Turquoise was used very, very heavily in Middle East, especially the Arabian countries. I don't know how many of you have seen mosque. How many of you seen mosque? Mausoleums? Gone inside? At least see the pictures, okay? Some of the famous mosques. They will be all using turquoise inside, ornamental stone, turquoise, a gemstone. Okay, and many of these were found by accident. They were not knowing much, but somehow they happened to see. Okay, they were able to understand. Okay, oh, something is happening here. They were trying to use all these things, pre-dawn stage, the initial stages. Jagannath Pandey, are you there in the class? Pandey?
Yes, sir.
Okay. Then comes the most important, Egyptian, Greek, and civilizations. Great civilization. Of course, I don't know how many of you have read history. So these are the most famous civilizations. They had desire for gemstones, yes, sapphire, diamond, ruby, metals also. What they did was they were able to find out the occurrences, record it. So they were keep on mining. Okay, they were using mainly gemstones. They were using mines. Egyptians, Babylonian, all civilizations. Even India, as long as 3,400. Okay, BC. Lapis lazuli. Some of the minerals they were using: lapis lazuli, amethyst, malachite, jasper, turquoise, all gem varieties. So you'll have non-gem varieties also, but they were trying to use mostly gem varieties. But beautiful. No? It looks beauty. Agate, beryl, chalcedony, gar, all beads. You try to see the ancient kings and all, no, they used to have all these things as ornamental stones. The part of the jewelry that is showing their wealth. Pharaohs. I don't know how many of you know about pharaohs? Prakash? Mr. Prakash? Mr. Prakash? Prakash, I'm noting down. He's not answering. Okay. Piyush? Piyush Bashanwal? I'm noting down the names. Sahil? Sahil Gawande?
Yes, sir.
Okay. Please tell me, have you heard of the term pharaohs?
No, sir.
Can you find out from your, do you have your mobile with you next to you?
Yes, sir, I have.
Find out.
Yes, yes, one
Do
minute,
some
sir.
work. Find out what is it. See the meaning of it. I could see that many of them are sleeping. I think I should start taking the attendance. Anyhow, I'm noting down the names.
Sir, it is related to something Egyptian kings.
Egypt, yes, Egyptian kings, Egyptian kings. Of course, they had the culture. They had a culture, so they're called pharaohs. Okay, so these kings were doing expeditions. Expert to Sinai. Sinai is a very famous place. Sinai Peninsula in Egypt and Sudan, mainly for turquoise. No, I told turquoise. Turquoise is very famous. And according to records, the first economic geologist was 2000 BC, my lord, Captain Harois. This is what history tells. Okay, these people they sank hundreds of shafts. Have anyone of you heard the term called shafts? Rhythm?
Yes, sir.
Can you tell what is a shaft? Have you heard of the term called shaft?
Something like a boat.
Can you be more clear? Your voice will be clear?
Sir, boat. Small boats.
Increase the volume in your computer, laptop,
Yes,
and your
yes.
mobile.
Sir, am I audible?
Yeah, better.
The small boat.
Hmm. Small boat. Oh, there's a
Yes.
raft. That's called raft. There's a lot of different raft and shaft. Do you have a mobile with you?
Yes, sir.
Come on, put shaft. Shaft in my minds.
Yes, sir.
Come on, see. Have knowledge. Very important. See, unless we learn something new, then what is the point in reading? What is the point in doing the course? shaft
It is
in
some.
mine, in a
It is
mine.
the machine which is used to excavate
Excavate, okay. Read some
excavate
more.
vertical tunnels.
Yeah, it's a vertical tunnel. It is just like a lift. It's just like a lift. You know, probably you must have used lift in your Radhakrishna Bhavan, or you must have used in lecture theatre. Okay, is it right? Lift always goes from ground to top, and top to bottom it comes to the ground. But whereas in shaft, the one from the surface it goes below. From the surface, okay, it goes below. It will go 100 meter below, 200 meter below, 300 meter below. So it can keep on going. Okay, is it right? In India itself, we have some shafts which are about 7,000 feet. One single shaft. One single shaft can go 7,000 feet. You can imagine how many meters. So this is called a separate process called shaft sinking by mining engineers. Okay, so they had hundreds of shafts along Red Sea for emerald mines. My lord, 250-meter deep. Some of the mines shafts were 400 men were working at a time. This is what the record tells. You know, the ancient persons were quite good in mining. They started developing a lot of mines. Yeah, then comes in an age where a lot of metal mining was going on. That means things were slowly improving. They started understanding how copper can be used, how bronze can be used, okay, how bronze can be made, alloy, okay. So Mesopotamians, Babylonians, Mesopotamians, the ancient mines of Sagu in Greece, okay, 2500 to 3356 BC, they were able to extract gold ores, multi-level mining, my lord, terrific, terrific, terrific. So this particular person, they brought stress. Okay, he wrote a first book called Book of Stones. This was the first mineralogy textbook. In those days, they all connected, no, mineralogy, petrology, economics, all connected. So he wrote the first book called Book of Stones. And there are certain places in southern part of Spain where you have 2,000 shafts, my lord, terrific. 150 meter, 15-meter deep. Okay, and he was the first person after the death of Christ. He was the first person. He grouped minerals in two types called and grouped minerals and recognized sulfide group. He felt that yes, there is a particular group of minerals which are very important for metal extraction, like copper sulfide, iron sulfide, lead sulfide, zinc sulfide. Then comes another scientific. That means things started developing. Mostly it started developing from Greece. You know, Archimedes, all these people, you know, his own group of people, so-called philosophers. In fact, philosophers were scientists basically. Okay, Agricola was the first man. Okay, he worked in Saxony mines in Germany. Erzberg is a very famous place in Germany. Okay, he wrote the first book called Beri Metallica. So you can imagine that means things start developing by 1400 after death. Okay, so deposits were classified into alluvial types and in situ types. People started understanding what are fissure veins, what are bedded deposits, what are stringers, what are seams, and what are stockworks. So people start understanding all these things. So you have to find out from books what all these things means. I'll send the PPT to all of you. In fact, he was asking our class representative, Rahul. What name? Yeah. नाम क्या है? Representative? Rahul? Yeah.
Raghav.
Raghav, he just asked me. I said, yeah, I'll definitely send it, but try to understand. Okay, I'll send the PPT today. Try to understand all these concepts.
Yes, sir.
So he says that according to the Agricola, ore channels are secondary features. Sorry, wow, great concept. Younger country rocks. This is called epigenetic later. That means science are developing. The ores are deposited for solution, circulate. Oh my God. All concepts, excellent concepts start coming out. What currently we call hydrothermal deposits, these people start discussing in 1500. Vedant Singh, Chitoria.
Yes, sir.
आजकल कहाँ हैं आप?
Sorry, sir.
Where are you?
Sir, at home.
At home. Which place?
Sir, I'm from Ajmer, Rajasthan.
Ajmer. Oh, good. Go to Kayar mines. Go to Kayar mines and see something.
Yes, sir.
Otherwise, go out from Ajmer towards Bilwada Road. A number of pegmatites are there. Try to see how they occur. No, you will understand.
Sure, sir.
Two to three of you, Ajmer people, try to go out of the city. Try to go and see outside. Okay,
Yes, sir.
you will understand. Always practical is more important. Learn theory, but you go to practical. Okay, now comes slowly things are changing from 17th and 18th century. Steno was a scientist. He argued that the ores are products of condensation from vapors. He gave a different concept. Vapor transport. Of course, recently Russians they talk about vapor transport. Okay, through fissures, an advanced concept long back. Enkel, once in 1725, Zimmermann, Germany. Okay, they talked about import hydrothermal solutions, water at high temperature, vapors of deep sea origin. Okay, they say that all contained or dissolved rock material. We'll study. When it comes to hydrothermal process, we'll study. Delius, okay, he talked about superficial alteration of ore, yeah, secondary minerals. This is where your proto-ores become enriched ores. The proto-ores, because of this process, it will become a enriched ore. So people start understanding these things. So once you understand the process, you can look for enriched ores, which are useful for industrial purposes. Yes, this is the great concept by Plutonis and Neptunus. So there are two great scientists. One is called James Hutton, a Scottish British geologist from Scotland in 1788. Another is A.G. Werner from Germany, from England and from Germany. Okay, so he proposed a theory called theory of the Earth, and he said that magmatic origin of rocks to all metal deposits. So he says that any type of deposits, if it is a gold deposit, uranium deposit, it is a limestone deposit, which is wrong definitely, and iron deposit. So he says that all the deposits are connected to the plutonic rocks, are called igneous rocks, formed by the igneous process. So that's why it's called a Plutonis. So this school of study, which dealt with the origin of deposits, and they said that everything is because of Plutonism. Probably they studied number of rock types where they were able to find, and most of the rocks are plutonic rocks. So they felt that irrespective of the rock type, it has to be plutonic. So they called Plutonists. Okay. A very strong school. Another is Werner from Germany. Naturally, something like this, like if you are coming from Haryana, definitely you will eat chapati. You will eat because a lot of wheat is available there. If you are coming from southern part of India, like what our royal is there, Vijayawada or some other place, you will eat rice because a lot of rice is there. Okay. If you are coming from China or from Taiwan, you will eat a lot of noodles because there is a stable food there. That's right. The same thing, Werner, who was working in Germany, he must have studied a lot of deposits within the sedimentary rocks. So he said that he was from Freiburg Mining Academy, very famous place. He wrote a paper on origin of veins in 1791, and he said that all the veins were formed by circulating waters from the primeval ocean, from the ancient ocean, deposited vein materials by chemical precipitation. That means he is talking about the oceanic water containing a lot of dissolved materials, and it is precipitating either on the surface of the ocean floor or the rocks below it. So this is called as the Neptunus, water-based. These were the two more major theories that were going on that particular time. Things are better. Saurabh Sangam is there. Is he attending the lecture? Saurabh Sangam.
Yes, sir.
Where are you nowadays, Saurabh Sangam?
I'm at home, sir. Jharkhand.
Yeah, I know all of us at home. Of course, I am in the laboratory.
Yes, sir.
Which place?
Jharkhand, Hazaribagh.
Hazaribagh, oh, wonderful. Did you go outside the home?
Not much, sir.
Oh, you should go out. You see, you should be adventurous. I mean, khatam ho gaya. We go to market and see people will move without mask also. Of course, I don't say that you should be careful, but you should go outside and see. Hazaribagh is a wonderful place. It's a place for geologists. Are you from geology or geophysics?
Geology, sir.
Geology, very good. Oh, you come to the right place. Come to the right place. Go and see. It's wonderful. Granite gneisses, pegmatites. You have mica-bearing pegmatites. You will have metal-bearing pegmatites. You will have the barren pegmatites, zoned pegmatites. Oh, wonderful place. Fantastic place. Hazaribagh, Nellore. Gudur, Bilwada, all these places are famous for. So you will have the plutonic aspects. No, you will start becoming a fan of James Hutton.
Sure.
Please. Okay. Then comes the 19th, 20th century. Things started becoming. Time started flying. So there was a scientist called Dabri. He studied the experimental concepts of ore deposits. He created artificial stannite in the laboratory because it is easy. You can melt the lead, easily. You can lead and you can crystallize it. So he was able to prepare this. The experimental mineralogy and petrology started coming out. Granitic magmas. Okay, he gave the concept that water for mineral deposits connected to granitic magmas. And Beaumont was another scientist. He said the segregation of chromium from magmatic deposits, which called a magmatic segregation deposit. Juan Cota, he wrote a book on treatise on ore deposits, a textbook for 2 decades. Okay, he wrote that deposit not a single stage. A deposit has multiple stages. You want to become a successful man, you cannot study in only one college. You have to study in some place and you have to go to another place. Is it right? IIT Bombay, IIT Roorkee, go to IIM Ahmedabad. Okay, is it right? That's what the mechanical engineers, electronic engineers, they do. They go with the MBA, then your package will be 40 lakhs, 50 lakhs, 60 lakhs. Whereas you study only in IIT Bombay, IIT Roorkee, your package will be 10 lakhs or 20 lakhs. Is it right? The same way, if a deposit has to form, it has to become a good deposit, then it should not be a single stage. It should be multiple stages, manifold genesis of the deposits, or multi-stage genesis of the deposits. Okay, so number of scientists, like you can see in the history or in the literature, Emmons, Van Hise, Vogt, all they talked about different processes. That's how the scientific development started developing. Sakshi, is it things are clear? Sakshi Rathod? Where are you from, Sakshi? Huh? Hyderabad. Oh, very nice. How come you reached Hyderabad? Rathod, how come you reached Hyderabad? Can you be more clear? Can you be more clear? No, your voice is not clear. Abdul, not clear. No, you have to set your computer, otherwise you will not get your internal marks. I'm very sorry, Sakshi. Okay, next. Yeah, then comes the most famous Vladimir Vladimir Lindgren, 1860. That means things start developing more and more science. You see, in 1800 and all Isaac Newton, all these people start coming up. No, so let us try to see what exactly Lindgren. Lindgren is said to be the father of economic geology. Okay, just like you talk about Newton in physics or Einstein in theory of relativity, nuclear energy, etc. So this man was economic geology. He was born in Sweden. He took interest at the age of 10. He studied from Royal Mining Academy, Freiburg. Yeah, yes. This is the place where Werner was there, Freiburg, Germany. Okay. He was born in Sweden, but he went to Germany. So that's why migration is very important for further going up. He said from Freiburg Mining Academy, he went to US. He sailed to US and he joined as a field assistant in Montana, very famous copper mine. His salary was $25 per month those days. Okay, then he was not happy. It was because he had a lot of fire in his stomach. So he joined USGS, United States Geological Survey, and he worked for 25 years. And he studied hundreds of deposits in western US, western part of US. Very famous place. All your Butte, Montana, Bingham, all those places. Then when he was doing all the work, he had a lot of interest in writing. So when he was writing, then the MIT, the Massachusetts Institute of Technology, they found, there's a great man who is doing a lot of work in economic geology. Come on, let us ask him to come and give a series of lectures. So he gave 2 years of series of lectures, 1909 to 1911. So when they saw all his lectures and papers, the University of MIT, they felt, yeah, here is a man who is suitable for our department to develop. So he was appointed as a professor of economic geology. Okay, and based on these lectures, he wrote the book called as Mineral Deposits in 1911 itself. Now it is 2021. See, you can imagine 110 years before he wrote the book. Excellent. Now also excellent Lindgren. We are going to study a lot of Lindgren's classification. Great man. Okay, so in fact, he was the person to propose Lindgren's classification of mineral deposits He was talking about hypothermal deposits. We will study all these things in hydrothermal, mesothermal, epithermal, telethermal, xenothermal, high-level concepts. So some of the concepts were recently worked out by a number of geologists, and they were able to come up with models for explaining the deposits. Like, for example, the direct mantle degassing, the metamorphic ones. This is the direct mantle degassing. This is a metamorphic model, and you have a magmatic model. So different models were proposed following the lines of Lindgren. He's a great man. Things are clear, Sumit Kumar? Sumit Kumar?
Yes, sir. Yes, sir.
Okay, what do you see there? You are seeing three pictures. What does it tell? What does it tell? Can you put your mind and see what is happening here? Why people are direct mantle degassing, metamorphic model, magmatic model? What for? What is this, all these things to do?
For perfect picture of subsurface.
Pardon?
So for perfect picture of the subsurface for better view.
No, your voice is absolutely not clear. If I talk like this, will it be clear to you?
Sorry, sir. So now it's clear?
Yeah, can you please be more clear and tell what these models are giving, what these diagrams are giving?
It's a diagram are showing that we are trying to look at the subsurface more clearly. That what
Yeah, 1 minute. 1 minute. Yeah. I'm sorry.
we are trying to look at the surface more clearly by creating the model what's beneath the subsurface.
Okay, what is written here? Direct mantle degassing.
Sorry, sir.
What is this direct mantle degassing?
In this, we are thinking that mantle is
What is this? What is this? And what is this? What is this? What are these things? What all these things has to do with?
the effects of magma on the subsurface, I guess.
What does it come out of magma?
Heat,
Heat.
variation in gravity,
Heat.
variation in rocks, different kind of rocks.
Okay.
Like
Only heat it comes out. That's all.
the heat.
What is this? What is this? Mantle degassing. What is the meaning of mantle degassing? Nowhere is heat is written here.
Gases are coming like from mantle heat.
How gas will come out? Where are the gases inside the mantle? How mantle consists of gases? What are the gases it consists of?
So like the subsurface can contain the carbon dioxide and other type of gases, poisonous gases that can be found on.
Do one thing. I think you may know who is talking, please.
Sumit.
Sumit, do one thing. Give a small seminar next week on mantle. I want you to give a talk on mantle. Okay.
So what should I write?
Mantle. You should give a lecture on mantle.
Okay, sir.
From the viewpoint of a geologist.
Yes, sir.
Okay, done. Okay. So, yes, anyway, for information to all the students, the previous slide said Lindgren's classification: hydrothermal, mesothermal, epithermal, telethermal. Okay, all these related to temperature, no doubt. Yes. Okay, but these are all basically all waters. These are all basically water coming out of the different parts of the crust or the mantle. Okay, with a very high temperature. They are high temperature fluids. Okay, so these high temperature fluids brings a lot of materials, and they are deposited in different parts of the crust. That is the main purpose. Okay, so for that you have to understand the mantle, you have to understand the crust, you have to understand the reactions, what is happening in the crust and the mantle, the different processes. So that's why I asked our gentleman to talk on mantle. Next week, Monday, you should give a lecture on mantle. Yeah, it's called mantle degassing. It's the metamorphic model. Anyhow, you will read all these things.
Yes, sir.
Yeah, sure. Yeah, this one is, of course, I don't know whether discussed or not. So these are the orogenic gold deposits which we are going to study. Major subductions and the shearing, the fluid production, a lot of things are happening here to give rise to gold deposits. Okay, so we will study all these things. Okay, we will study about the chromite deposits in the next classes. Study diamond deposits. Okay, so these are the minerals you must have come across in in books, you please have an idea. You have to read about oxides, hematite, magnetite. Okay, you should read about hydroxide, limonite, goethite, sulfides, pyrite, pyrrhotite, chalcopyrite, galena. Okay, sulfide like chalcopyrite. Okay. Yeah, we were talking about Banadine formation in the class. No, these are the Banadine. Yeah, yes. These are the chert band. These are the Jasper band, SiO2 rich. And these brown, yellow, these gray ones, they are the iron bearing ones. So if you see the bulk of the rock, it consists mostly of Jasper, which is chert, which is basically a SiO2. So the component of SiO2 is very high, whereas the component of the gray material is less. So this becomes a proton for iron. Is it right? Is it right? Because Deagle, Mr. Vikas Deagle, Mr. Vikas Deagle, yeah, so gaya. Yash Ingani,
Yes, sir.
yeah. Find out what your friend Vikas Deagle is doing after the class, not now.
Okay,
Not
sir.
tell him sir was calling and he did not answer, so mark absent.
Okay, sir.
Okay, so yeah. So what did you understand, Yash, this class?
We have been discussing the origin of how different types of mineral have been used in human history.
Very good.
And now we are looking at planet iron formation, and we are discussing how the stripes are of iron and silica.
Very good, very good, very good. So where are you from, Yash?
Sir, Chandrapur, Maharashtra.
Oh, Maharashtra. Okay, very good. It's a beautiful place for coal deposits.
Yes,
Very
sir.
beautiful
We
place
have
for coal.
many mines here, coal mines.
Yeah, I know a lot of mines are there. There is a beautiful fluoride deposit here, Chandrapur. I will exactly tell next week what is the location. If you get time and things are better, you could just go to the place. There's a beautiful fluoride mine. You have once again the cherts, sedimentary rocks, metamorphosed sedimentary rocks, the host rocks, and you have a lot of fluoride veins. So fluoride is extracted. You have barite also there, calcite is there. A lot of interesting things are there in that mine. You can just go and visit. Quite nearby, it's about 10-15 kilometers from your place.
Yes, sir.
I don't know the village name, but I'll find out. You can go into the website of Maharashtra Mineral Development Corporation and you can type fluoride deposit.
Maharashtra Mineral Development Corporation. Okay.
Yeah. Then you can type and you can see, okay?
Yes, sir.
Yeah. Practically is important. So shall we come out of the slides?
Yeah.
Okay. So we have Yash, Sumit Kumar,
Yes, sir.
Pakshi Rathod. You have to set your mic properly, otherwise you will be in trouble. Saurabh Sangam.
Yes, sir.
Looks as if he is not attending the class. Akshat
Sir, I'm here,
Punia.
sir.
Akshat
Yes, sir.
Punia.
Yes, sir.
If I don't get the response, then I will